Hey everybody, it's Mr. Brew, live at Infinity the Math Institute, and we are super excited about this premiere. We're trying out a little bit of a live homework help. It's designed so anybody, I don't care if you're taking discrete mathematics in college or if you're in first grade trying to figure out arrays and counting by twos, we're here to answer any and all questions related to math in a live setting. The other thing this does is it gives you an opportunity to see the infinity way of teaching math. So that way, if you were ever wondering what makes us different, and we're always telling you, just trust us, it's the best ever, and we try to explain it to you, of course, and we try to verbalize exactly what it is we do by concentrating on the foundations, the fundamentals, by concentrating on vocabulary and having a mix of concept understanding and rote memorization. You're going to have to memorize your multiplication tables. I'm so sorry. You're going to have to memorize the law of cosines or the quadratic formula or your squares and cubes. You're going to have to memorize some stuff. But here at Infinity, we try to make you memorize this stuff really quick and then use it in a lot of context. So that way, it's like learning a new word in English. If you learn the word and then start using it in context a lot, it just becomes part of your vocabulary. Well, the foundational lessons of infinity will become part of your toolbox. And you could ask my kids, I got kids who are taking calculus right now, and I'm still always referring back to the fundamentals, whether it's number classification or the rules of equations or how to graph a line or the x-intercept or the y-intercept. All these things tie in together. Math is math is just its own language, and one thing builds off another. So, we're getting quite a bit of people joining us, and I'm waiting for the producer to give me the go ahead because we've got some questions. By the way, if you want to get on the question list when there's time at the end of each lesson, we're going to be going through the comments in order to find out what questions people want in real time. Also, we're going to be doing this every Wednesday at 7 o'clock Pacific. So if you know our phone number, 702 768 1777, you could always text us your problems, especially in the hour leading up to the broadcast, so we could set it up. Um, Otherwise, if we have time, we're going to be answering as many questions as possible right here in the comments section. You could simply take a picture of the problem and post it as a comment, or you could just ask it regular. We're going to be doing this on both YouTube and Facebook, so we'll be available on either platform. And boy, what better thing to do than gather the family around on a Wednesday night doing some math? I don't know what else you'd rather do, but I'm right where I want to be. So, are we ready to get started? One thing I do know is Celeste wrote in our first question. Celeste is an 8th grade student. She's taking algebra at Somerset Academy. And I just loved her question. That's why I wanted to start off with it. A lot of times kids get these questions and they've been working really hard on learning these concepts, but then they ask the question in a different format and it throws the kids all off. I don't know if you could see what I'm showing right here, but the question is solve each inequality, and there's 6 inequalities on the thing. The thing that gave Celeste the problem is that they're saying give the solution in set builder notation. And Celeste didn't know what she was referring to. They gave you an example. And right here it says e.g. means for example. All right? Then the example of how they want the question answered is the set of numbers. That's why you got the squiggle right there. That squiggle bracket refers to the set of numbers, where x is an element of the real numbers. That's what that's saying. The answer, it's more than one answer. Anytime you have more than one answer, you have to have set notation. For example, if the answer was 3 or 5, you would write the set 3 comma 5. Because there's more than one answer, you need to use set notation. So we have set notation, and x, which is what we're solving for, is an element of the real numbers. It's not an integer. It's not well, it is an integer and a whole number, but it's everything in between. Sometimes you might say, if we were looking for how many school buses did we need to take to the park, well, we need at least 2 school buses. So x would be an element of the natural numbers, because you can't have half a school bus or a decimal of a school bus. So you would say x is an element of the natural numbers. X is an element of the natural numbers, and that is an n with a double stem, whereas real numbers is r with a double stem. So that's why they say real numbers, because it could be any of the fractions, decimals, even the irrational numbers such as the square root of 2. If it's in that less than 2, they're saying x is less than 2. If it's less than 2, it doesn't matter if it's rational, irrational, whatever. The square root of 2, 1/2, 1, -3, all those numbers, all those real numbers work. Now the problem is, Celeste was used to saying the answer is x is less than 2. She was able to do that no problem. She just didn't like the set builder notation. Guess what? For all of these problems, it's going to be in set builder notation. And for all of these problems, x is going to be an element of the real numbers. So Celeste, just do the problem the way you know how, and instead of saying x is less than 2, say the whole thing. X is an element of the real numbers such that, sorry, I didn't tell you about this line right here. This big line right here, that big vertical line, it means such that. So x is an element of the real numbers such that x is less than 2. So let's take a look at a real problem and see if we're able to emulate exactly what we just saw. Now, one thing Celeste didn't have a problem with was solving inequalities. Just in case you have problems with it, let me review one thing really quick. Inequalities are exactly the same thing as equations. Anything you do to one side, you must do to the other. The only difference is that when you're working with inequalities, if you multiply or divide by a negative number, you must flip the inequality. That's the only trick you need to remember. So looking at this problem right here, negative x over 3 is greater than negative 10 over 9. So the first thing we have to do is multiply both sides by negative 3, right? That would get rid of the negative and the 3, which is the objective. We want to isolate the variable. So anything I do to one side, I do to the entire other side. I multiply both sides by negative 3. The negative 3 and the negative 3 cancel, leaving me with x. I multiplied by a negative number, so that means I flip the inequality. X is less than, and then the negatives cancel out. A negative times a negative is a positive. The 9 and the 3 turn into a 1 and a 3, just like so. So x is less than 10 over 3. Celeste, I know you're comfortable answering the question that way, and you're done. The only thing is you have to recognize that they're looking for set builder notation, so I'm actually going to write the set of numbers where x is an element of the real numbers such that x is less than 10 over 3. All right? And guys, this is when you start looking really cool and you're doing all this cool math stuff. You're not doing anything special. You're still just saying x is less than 10 over 3. But notice it starts to look like you see on the TV shows when they're doing lots of mathy stuff. It's because we're just explaining the answer fully. So let's try one more quick one before we call it a day on these inequalities. I'm looking at x divided by 4, or x over 4, is greater than 5 over 4. All right? I mean, I don't know. if you could see what I see. But the shortcut here is x is going to be greater than 5. But maybe you didn't notice that. So let's take it step by step. What's the first thing we do? We multiply both sides by 4 in order to isolate the variable. The 4's over here cancel. The 4's over here cancel. And like I saw right away, x is greater than 5. But what do they want? We want set builder notation, or we want it answered properly, is the way they should say it. So, again, x is an element of the real numbers, such that x is greater than 5. All right, so there's a quick little lesson on inequalities and answering properly in set builder notation. I'll let you guys take a look at the next problem as I get a sip of water. Make this a little smaller so you guys could see it. There you go. This question was brought to us by Seema. She's in 11th grade, and she goes to Spring Valley High School. Yesterday, this was one of her homework problems. Create a polynomial that satisfies the following conditions. All right? So first things first, a polynomial is just an expression with one or more terms. It's not specific. A monomial is one term. A binomial is 2 terms. A trinomial, guess. I'll wait. Right, 3 terms. A polynomial is however many terms. A polygon, right? A pentagon is 5 sides. A hexagon is 6 sides. A polygon is however many sides. So a polynomial is however many terms. Terms, all right, let's write down some vocabulary here that you need to know. Terms, you should consider the same variable and the same exponent. Same variable and same exponent. And if you have the correct combination of the same variables and the same exponents, then you can combine like terms, which is something you're going to have to be very fluent at. Anytime you see something's the same, you can combine them. For example, if you had x plus y, you cannot combine them. They're not the same variable. But if you had x plus x, you would call that 2x. Same thing, if you had x squared plus x, you can't combine them. But if you have x squared plus x squared, then you would have 2x squared. And that's the trick. Just remember, 2ab can go with 3ab because they both have the a to the first power, b to the first power. They're like terms. But 2ab plus 3ab squared, different terms because they have different variables or different exponents. So this would be different terms. Same variable, same exponent. Okay, very good. Sorry, I just had to make sure we're all clear on what terms are and how we can combine them. So the first question is 3 terms and degree 5. The degree of a polynomial is simply the highest exponent. And you should know that we like to put the biggest exponents at the front of the expression and the smallest exponents or the constant at the end of the expression. The only reason we do this is to stay organized, and it makes it really easy for us to see what the degree of the polynomial is. So if it's going to be a degree 5 polynomial, that means the biggest exponent is going to be 5. So let's just start out and we'll throw in right away. Let's throw in an x to the 5th. As long as there's no other exponent higher than 5, this is a degree 5 polynomial. 3 terms. Let's throw in a couple more terms where the exponent is less than 5. We could do plus x to the 4th plus x to the 3rd. That's the simplest way to do it. We could go crazy. We could go 12x to the 5th minus x plus 135. That's 3 terms. 12x to the 5th is the first term, negative x is the second term, plus 135 is the third term. You could be as complicated or easy as you want as long as there's 3 terms and the biggest exponent is a 5. So let's take a look at this one. This is 2 terms, degree 2, with no constants. All right, constants is this plus 135, has no variable. All right, a constant term is a term with no variable. So I could do this. Let's keep it simple. 2 terms, degree 2. So the easiest leading term would be x squared. So that way the biggest exponent will be 2, meaning it's a degree 2. Then I could add an x, and now I've got 2 terms, second degree, and there's no constants, right? There's no number there. So I've fulfilled the criteria. Finally, the most complicated one, which really, to be honest, isn't all that complicated at all. 5 terms. Notice, if it's 5 terms, it's going to have to be at least a degree 5, assuming we're working with one variable, of course. So let's do the easiest one, and then we'll do another one super complicated. How about that? The leading coefficient is negative, so we'll go negative x to the 5th, and then what are my next 4 terms? Let's go plus x to the 4th, plus x to the 3rd, plus x squared, plus x. Oh, and that's 5 terms already. So I don't even need a constant. I almost threw in a constant, but then I would have made a mistake. So there you go. 5 terms, degree 5. The leading coefficient is negative. And if you wanted to be a jerk and make your teacher work, then you could just say negative 143 x to the 5th minus 77 x to the 3rd plus 41.2 x squared minus square root of 2x plus pi. Same thing, right? 5 terms, degree 5, and the leading coefficient is negative. Polynomials are not that big a deal. Next, we're going to be looking at everybody's favorite thing to do, a combination of word problems with graphing, real life situations. Oh my God, it's so fun. It's not miserable. You know why you guys are miserable doing these problems? Because as soon as you see it, you get miserable. And then the whole experience is miserable. Relax. Read the question. Use your foundational understanding of math to solve it. I'll give you a second to read the problem. All right. Well, this question is from Mahali. She goes to Cornerstone Christian Academy. She's an 8th grader, and as you could probably tell by the problem, she's in algebra. All right, Mahali, what do we got here? Reading. Oh, I guess that's the section. A bookstore sells textbooks for $80 each and notebooks for $4 each. The bookstore would like to sell $800 in merchandise by the end of the week. Instead of jumping into the problem, I'm going to take a look around. Write a linear equation that describes the problem. I had a feeling that was coming. Graph the linear equation to make sure to label both axes with the appropriate titles. I saw that coming too when I saw the graph. And then use the graph to approximate how many textbooks the bookstore must sell if it sells 40 notebooks. All straightforward, no surprises, but sometimes there is a surprise. So please read the question. Not only that, now I'm going to go back and I'm going to read the question again, because that's the only way you know if you're answering the question properly and you're not missing something. Slow down. So, when I was looking around, I noticed there's an N and a T. Guess what? I figured out already they're looking for N to equal notebooks and T to equal textbooks. I hope you all saw that right away, because these are the little things that make the question so easy to solve, just one step at a time. Noticing that N and that T. Very important. All right, so we need to get a total of $800. And we're going to charge $80 for a notebook and $80 for a textbook and $4 for a notebook. So how much money am I going to get? I'm going to get $4 times how many notebooks I sell, right? If I sell 10 notebooks, I get 40. If I sell one notebook, I get 4, right? N is the number of notebooks times $4. Plus, I'm going to get $80 times however many textbooks I sell. So if I sell one textbook, I get $80. If I sell 2 textbooks, $160. 10 textbooks, $800. And how much do I want to sell? I want to sell exactly $800. All right? Now, if you want to get a real world context, I would have made this an inequality and said it's got to be greater than 800, right? Because when you're in business, you don't say I want to make 800. You say I want to make more than 800 or at least 800. Anyway, we're going to go with it because that's what the question says. Now, that is a linear equation in standard form. Notice it has the beautiful AX plus BY equals C formation. So that is the linear equation. Okay? Now, they want us to graph it. For those of you who know your linear equations, you know that standard form is not an effective way to graph a linear equation. It's usually best to put it into slope-intercept form, right? Y equals mx plus b. But here, we don't have a y-axis and an x-axis. I noticed right away that this is an n and this is a t. So in this particular case, I'm going to call this the n-axis and the t-axis. So instead of y, I have n. N is equal to the slope times the x, which in this case is t, plus b, which is the y-intercept, right? Y equals mx plus b. And all I'm going to do is I'm going to take my original equation and I'm going to solve for n. Just like if that said 4x plus 80y equals 800. So, in order to solve that, why don't I move this over here so we have plenty of room? I feel like my eyes are crossing from looking at these computer screens too much. Are my eyes crossing? All right, so given this in standard form, it's very easy. I'm going to subtract 80t from both sides. And I end up with 4n equals negative 80t plus 800. Right? This is a constant. This is a variable. So they are not like terms. So I cannot combine them, of course, right? Then the next thing I need to do is divide both sides by 4. All right, now listen, when I divide this side of the equation by 4, I must divide the entire other side of the equation by 4, not just part of it. Very important. 4 over 4 is 1. 1 times n leaves me with n. Equals negative 80 divided by 4 is going to be negative 20. T plus 800 divided by 4 is going to be 200. And that should show me that m, the slope, is equal to negative 20. So I go down 20, right 1. And the y-intercept is positive 200. All right. So now I can rewrite this as n equals negative 20t plus 200. My y-intercept is at 200. And then I go down 20 over 1. But I don't have 1, 2, 3, and 4 labeled. I have 5. So if I go down 20 over 1, that means I go down 100 over 5. You guys see how I did that? I went down 100 over 5 because down 100 is negative 100. Right 5 is over 5, which is equal to negative 20. And my slope is negative 20. I just changed it to negative 100 over 5. I'll also be able to do that again. Down 100 over 5. Oops, let me get rid of that slope explanation. There we go. Down 100 over 5, down 100 over 5, and there's my graph of a perfect linear equation. And they wanted us to label it. We already said N is notebooks and T is textbooks. And then the final question says, use the graph to approximate how many textbooks the bookstore must sell if it sells 40 notebooks. And that's why they say it approximate. So 40 notebooks is right about here. If we sell 40 notebooks, it looks like it's about 8. Right? This middle part would be 7.5. It's a little bit past the middle. So I'm going to say that textbooks would be approximately 8. This means approximately because they asked me to approximate. All right? One thing I want to address just while we happen to be on this graph. Thanks, Mahali. This is a really, really great question. I want you to notice the intercepts. All right? You should recognize that the y-intercept is the value of y when x is 0. And you could see it's 200 in this case. So that means when textbooks is 0, or when I sell no textbooks, I must sell 200 notebooks. That's why the intercepts are going to become really important as you progress through your math classes. When you sell 0 textbooks, I must sell 200 notebooks. And guess what the x-intercept is? Yeah, that's exactly right. The x-intercept is the value of x when y is 0. They also call this the root. And it's very important. You're going to see the roots a lot in your future math classes. So roots are just x-intercepts, and x-intercepts are just the value of x when y equals 0, or where it crosses the x-axis. You could see it crosses when y is 0, x is 10. And in real life, that means if I sell 0 notebooks, then I must sell 10 textbooks. And that's the great thing. All right? And the last thing I'm going to say is if this was an inequality and I had said, oh, I want to make at least $800, then all I would have done is shaded everything over here. Because if I sold 15 textbooks and 150 notebooks, I'd be right there, and that would qualify. I would have made over $800. So the inequality is just more relative to real life. The only difference is I would shade the greater than portion of the graph. What do you guys think? It's not that bad, right? All of this math, guys, I heard some of the people telling me, my pre-calc girl is saying, oh, I don't want to go into calculus. And I'm like, why? I'm going to do the same thing. We're going to learn one tiny lesson beyond what you already know. And then I'm going to teach you one more lesson beyond what you already know. And all it does is build, 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 build. And the great thing is you're never going to forget your previous lessons when you work with me, because we're going to constantly be using the previous lessons that you've done. And that's it. Oh, I'm seeing some of you guys that are watching Esteban Avila. You guys got to know that you guys have a present enlisted hero in this country. Esteban, he's always going back and forth to Asia and California to serve our country. Thank you. Francisco, hello. Tamara, my beautiful sister. LaShawn. Mateo, one of my favorite students. He's all the way in South America watching us live on Infinity the Math Institute. Sandra, LaShawn, I see you guys over there, and I really appreciate you guys watching as well. And please, tell your friends, send in your pictures. You know, it doesn't even, I don't even care. I'll give you guys life advice, all right? If this is the only time there's only going to be 2 or 3 people here, it's going to get crazy. So whatever you guys want to talk about, I'm here to help you out. All right? You got problems with your teacher, principal, parents, ask me. I'll tell you how to take care of it, where everybody will be happy. But mostly, I really want to concentrate on the math, because that's my favorite thing to talk about. So, we talked a lot about algebra today. We do have both in-class and online classes for algebra. On Mondays and Wednesdays, they're going to be teaching algebra at 5 o'clock. And that's every Monday and Wednesday online at 5 o'clock. If you prefer to come in person, Tuesdays and Thursdays, 5 o'clock. All right? And you get the Infinity Pack, all right? About half the price of our competition, and you get unlimited classes. So with the Infinity Pack for just $300 a month, you get unlimited classes, which could also count for every day of algebra. You could come online Mondays and Wednesdays. You could come in person on Tuesdays and Thursdays. And you could come to our in-person homework help on Fridays from 4 till 6. It is the absolute best value. And we're always here for you. You're part of the family. Hey, Mickey, how are you? So, yeah, algebra every day at 5 o'clock. Online at Mondays and Wednesdays, and in person on Tuesdays and Thursdays. All you got to do is give us a phone call if you have any questions. Our entire schedule is always available. And we just had a bunch of new tutors interviewing. We have the best math tutors here, and I think we might have just picked up a couple of really, really good ones. So our schedule is always expanding. If you have a special needs, whether it be because you're far behind or you're way ahead, we're here for you. We got one-on-one classes. If you want to jump in and just start learning the infinity way so that way you're guaranteed to succeed for the rest of your math career, give us a call. Join one of our supplemental classes, or we'll create a new class for you with all this great talent we're recruiting for teaching. All of our teachers make double what they pay at the competition, and they're all either licensed or previously licensed and no longer teaching. We have plenty of retired teachers, we have current teachers, we have substitute teachers. All we look for in teachers at Infinity the Math Institute is that you're a great teacher and you're great at math. And believe me, that's a lot harder to come by than it may sound. Visit our website, themathinstitute.com. There you can find testimonials. You can find out our price list. We are the only math tutoring institute that puts all our prices right on the front page of the website. It's so frustrating. You go to any other tutoring website, you have to call them or contact them or give them your email address because they're trying to get you in their database. I know what they're doing, and you know what they're doing too. We don't do that. We don't have contracts. Every single other tutoring institute, contracts, because they need to plan and they need to prepare and they need to know what income is coming. We need to know that too, but people don't like contracts, so we don't have contracts. And we're so good that if you got the means, you're going to keep coming back. And if you don't, we usually find a way. We're here. We're family. Anything we can do. All right? Most important, tell your friends about this live session. Every Wednesday at 7 o'clock, it's going to be doing some math. I'm going to be answering some questions. I'm going to be going off on a diatribe about why we're the best math institute in the world. Not just Las Vegas. I'm online. I'm talking to you guys in South America, Europe, Florida, New York, Las Vegas. We are the premier math tutoring institute. So anybody, if you have any math problems, come to Infinity, because we don't give you math problems, we give you solutions. Johnny Bruce signing off. Thank you for your support.